All right, this lesson is on decimals, part 9, comparing decimals through thousandths. A decimal number is any number that is on the right side of the decimal point. So here we have 6/10ths, and you can see the 6 is on the right. And 378 thousandths, you can see the 3, the 7, and the 8 are on the right side of the decimal point. And it represents a value that is less than 1 whole. So this would be 1 whole. And if I lay this on top of our 6/10ths, you can see that the blue part is less. And if I lay it on top of the 378 thousandths, you can see that the red part here is less than 1 whole. So it's less than 1 whole. And comparing means that we take the two numbers and we put them side by side, one on the left side and one on the right side. And we're comparing to see if the left one is going to be greater than the one on the right. Is it going to be less than the one on the right or equal to the one on the right? So again, for example, we have 6/10ths here on the left, and we're comparing it to 378 thousandths on the right side. And at first glance, it looks like the 378 is a lot larger. Most people would see this and think, well, this is greater. And let me show you that if you were comparing whole numbers, this 6 and 378, that would be true. For example, if this was just a pile of 6 pieces of paper, right? A couple, right? And 378, it would just go even past the page. And we would say that, well, 378, is definitely greater. And you would read this as 6 is less than 378. The problem with this is that these are whole numbers. And today we are dealing with decimal numbers. And decimals, it's like a different set of rules because we said that our decimal numbers aren't even equal to 1 whole. So when you see 378 thousandths, that's not even equal to 1 whole. It's just 1 whole that's been cut up into 1,000 slices, and then 378 are shaded. So it's a different set of rules. Our job today is to make sure that our decimal place values are balanced. And the whole idea is that before we decide if they are greater, less than, or equal, we want to make sure that we add the zero. So for example, 0.6 for the here would be our 6/10ths. We have 0, decimal point, and 6. Here on the right, we have 3/10ths, 7 in the hundredths, and 8. And the rule in math is that when you're doing decimals, you have to be balanced. And so what we do is we add zeros. So here we have thousandths on the bottom, but tenths. And the rule is we have to make them the top number into thousandths. So now when we compare our two numbers, it is now 6/10ths is equivalent to 600 thousandths. In other words, if I were to add these zeros, 600 is greater than 378. In other words, 600 thousandths is greater than 378 thousandths, and we would express this as the original problem is 6/10ths is greater than 378 thousandths. I can show that on the model. Here we have 6/10ths, shaded blue. And if we compare this, you'll see that the 6/10ths, which is this line here, is greater than the 378. Remember, the 378 thousandths is just really cut into small pieces, but you just have 378 of them, right? So yeah, so we have to compare. Our job today is to make sure they're balanced. And in other words, we want to compare apples to apples, or in other words, tenths to tenths, or hundredths to hundredths, or thousandths to thousandths. And it's kind of like makes me think of that movie, The Karate Kid, where you have Mr. Miyagi is training Danielson, and he always says balance is key, and that's true for decimals. So, for example, here on the left, if we have two numbers, these are not balanced. This number here on the left has three decimal place values, but this has only one, and we must balance that. So in this case, I would have to add 2, right? And then we become balanced, and now we're allowed to compare. Now that I see that 300 thousandths is greater than 256, and we would then put in our symbol for a greater than, less than, or equal to. So that's what we're doing today. This would also be true for hundredths. Our last model, we were showing the blue tenths. This is an example of hundredths. So for example, here we have 30 hundredths, and we are comparing that to 250 thousandths here on the right. And you can see that even though that's 30, right, and that's 250 thousandths, this is still a greater number. So balance is key, remember? What do? We have to add our 0 to make sure that we are balanced. And then we would say that 300 thousandths would be greater than 250 thousandths. But remember that when you would read this problem, you would go back to the original. This problem would be read as 30 hundredths is greater than 250 thousandths. So remember, the balance is key. Let's see if we can solve some problems. I'll try to move quickly. So remember, we want to balance the decimals left and right, and then we just, like any other comparing number, we compare from the digits from left to right. Directions, compare, right, greater than, less than, or equal. So here we have 39 hundredths to 42 hundredths. Are we balanced? Yes. So this is very, very easy to compare. That 42 hundredths is greater. So usually I would tell the kids to circle, pretend that's a pizza, and this is your hungry alligator. This would read 39 hundredths is less than 42 hundredths. 26 hundredths compared to 23. Are we balanced left and right? Yes, we're balanced. So 26 hundredths is greater. So pretend that's a pizza, right? And you're hungry alligator. This would read as 26 hundredths is greater than 23 hundredths. 6 tenths, and we're comparing it to 54 hundredths. Are they balanced? No, it is not balanced. So our job is to balance it. We can show this here on the place value chart. This would be 6 tenths, and if I were to write this out, that would be 54 hundredths. So we would just have to add a 0. So I'm just going to add a 0. You don't have to use a place value chart. I'm just using that just to show that a little bit more clearly today. And you can see here that 60 hundredths would be greater. So this would read as 60 hundredths is greater than 54 hundredths. Here's a mixed number, 1 and 15 hundredths compared to 1 and 3 tenths. Are we balanced? No. If we were to show this, it would be 1 and 15 hundredths compared to 1 and 3 tenths. So our job is to balance, right? We would just simply add a 0. And now we can see that the 1 to 1 is the same, but the 1 in the tenths is not the same as the 3. The 3 is actually greater. And this would read as 1 and 15 hundredths is less than 1 and 3 tenths. Remember, we read the original problem first. Here we go. Here's some more of our thousandths. Remember, apples to apples. In other words, tenths to tenths, hundredths to hundredths, thousandths to thousandths. So we have to make sure we're balanced. 5 and 4 tenths compared to 5 and 243 thousandths. Are we balanced? No, we are not balanced. Balance is key, right? So we're going to balance it. I can show that here. 5 and 4 tenths. And we're comparing it on the place value chart to 5 and 243 thousandths. So our job would be to add our two zeros to balance it. And now when we compare, 5 and 5 is the same, but the 4/10 is not the same as the 2. This is greater. So we would read this as 5 and 4/10 is greater than 5 and 243 thousandths. Excuse me. 2 and 47 thousandths compared to 2 and 407 thousandths. Are we balanced? Yes, we are balanced because we have the same amount of decimal place values, so we can just compare digit to digit. 2 and 2 is the same, but in the tenths, 0 and 4 are not the same. In this case, 204, 2 and 407 thousandths is less than that one. For time's sake, I'm going to move a little bit quicker. 5 and 300 thousandths compared to 5 and 3/10. Are we balanced? No. So we just have to balance it by adding our zeros. And this I can see is actually equivalent. It is equal. We would read this as 5 and 300 thousandths is equal to 5 and 3/10. This is an interesting one. Here we have 7 compared to 6 and 759 thousandths. And again, most people would see this is a lot bigger, but it's really not. Are we balanced? No, we are not balanced. This does not show a decimal point, but in this case, we need a decimal point. So I would read this as 7, right? This bottom number would be 6 and 759 thousandths. We said balance is key, right? Apples to apples. So we're going to add our decimal and 3 zeros. I'm going to show that up here as well. Now when we compare, we start with our ones, and 7 is not the same as 6. 7 is greater. So we would say, read this as 7 is greater than 6 and 759 thousandths. All right, everybody, hope this helped today, and we'll see you next time.